Hi everyone, welcome back. We are going to continue looking through our Chapter 2 guided notes. We have been working through solving linear equations. We're playing around with the ideas here of distributing to drop parentheses first, of course, if we have sets of parentheses. And then looking at the equation, if we have fractions, maybe we'll want to multiply by the LCD to cancel fractions and then progress through the problem. As a reminder, you'll use the opposite operation to move a term or part of a term to the opposite side of the equals. And then, of course, you want to isolate the indicated variable. That's going to be really important when we look at literal equations, when we're actually solving an equation for a specific variable when we have so many other variables in that equation as well. So it's going to get very interesting very soon. Not that this isn't interesting, because it is, right? Of course, it is. All right, so let's continue with problem number 4 on page 8 of 17. Let's check it out. So what I've done for problem number 4 here is I've actually separated each of the terms just to make it easier to see. In this case, according to the strategy that we've been using, we would look at all 4 terms and we would say, okay, we have 4 fractions and we know our first denominators are 5, our other denominators are 3. So if we needed an LCD, we would use 15. Good morning, Rachel. I see you. I'm checking you in now. So our LCD in this case is going to be 15. So we're going to take each term, place them inside sets of parentheses so that we can note that we are going to multiply each term by the 15. If your heart desires, you can write 15 over 1 for each of these. Totally up to you. Doesn't matter. These are your notes. Okay? For our first term, notice 5 can go into 15 3 times. And what we're left with is 3 times 8a. So that's going to give us 24a. Be really careful as you progress through these problems because I think it's helpful to simplify and multiply each individual term as you move from left to right. So again, 5 goes into 15 3 times and we have 3 times 12. That's going to give us a positive 36 is equal to. Same thing here, 3 goes into 15 5 times, and we have 5 times 4 times a, which is 20a, plus, and then we see that 3 goes into 15 5 times, and you have 2 times 5, which is 10. Perfect. At this point, notice we have only 4 terms again. Notice we have variables on either side of the equation. I personally would want to bring the 20a over. The other piece of advice I gave to you is please do not move the constant terms first. Save those for last. You want to move the higher degree terms first, meaning if you have a 24a and a 20a, you want to move the 20a first. So we're going to bring the 20a over so that your variables are on the same side of the equation. That leaves you with 24a minus 20a, which is 4a. We're going to bring down the positive 36. We're going to bring down the equals. Notice 20a minus 20a is 0, but I'm not going to write 0 because 0 plus 10 is simply 10. Next, we're going to focus on isolating our variables. So we're going to subtract the 36 from both sides. And if we subtract 36 from both sides, we have 4a. These cancel, leaving you with a 0. 4a plus 0 is still 4a. Bring down the equals. And then 10 minus 36 is negative 26. Last step, we have 4 times a. The opposite of times is divide. So we're going to divide both sides by the coefficient, which is 4. So 4 into 4 is 1, not 0. So it's 1a, which is just a. And then I want you to notice that if a is equal to negative 26 over 4, these are both even numbers, so we're definitely going to reduce. Notice here that we can divide both of these by a 2. So that means a is equal to negative 13 over 2. For those of you who worked on this last class, if you had negative 13 halves, that is awesome. I'm hopeful that everyone found this approach to be helpful, and I hope that you're developing this style and incorporating it into your strategy for solving linear equations. We are going to save problem number 5 for when we meet in our Zoom meeting, which will be after we finish our Chapter 2 notes. Once we finish our Chapter 2 notes, we'll be ready to take our first test. So I would like to have us get together in our Zoom session to review everything. I'll let you know when that is. It probably won't be this week because we still have so many pages to cover in our notes. So I anticipate that maybe Monday or Tuesday of next week we'll be meeting in Zoom, but I'll let you know. Let's go back to the notes. Okay, let's turn the page and move into our formulas section. So the section below has an assortment of formulas that you have to commit to memory and know how to use. Practice makes perfect. So the first formula we're going to use a lot. We're going to use simple interest. We'll see it in this unit, obviously. We're going to see it in Chapter 5 very, very heavily. So I want you to become comfortable with simple interest formula. Let's start off with what the heck these variables even represent. So I, in this case, represents our simple interest. Remember that interest is the amount you earn. Okay, so it's the amount you earn. If you invest money, you're going to earn interest. If you owe money, you're going to earn interest, right? That just means you have to pay off that interest in addition to whatever you were loaned. The P stands for principal. Okay, the principal amount. When you think of principal, I want you to think of initial investment. Yes, Hannah, that's fantastic. That'll make these problems a lot easier. So the principal is your initial investment. It's your principal investment, right? It could also be that initial amount of money you borrow. So really I should say, or initial loan amount, right? Because the principal could essentially be the amount of money you're going to borrow too. If you're borrowing $5,000, that's principal. If you're investing $5,000, that's principal. R represents the rate of growth. So I want you to think about this logically. If we're talking about the rate of growth, it has to be a percent. Your account will grow by a certain percentage. So what I'd like to note here is that for the rate, your percent must be turned into a decimal. Okay, you want to turn your percentage into a decimal. We can easily do this by dividing the percent by 100. Okay, so for example, let's say, and I'm going to write it up here because why not, we have this space. Let's say that I give you a percentage of 23%, right? If you want to turn 23% into a decimal, you can simply move the decimal from where it is, which is at the end of the 3, right? It comes after that whole value, and move it 2 places to the left. So essentially this becomes 0.23. But another way to think about this is to take that percentage, which is 23, and you can plug it into your calculator if you'd like, and you divide by 100. That'll give you 0.23. As another example, what if your percentage of growth is 1.5%? So now we're talking definitely more than a savings account, but maybe less than a mutual loan, so to speak. So 1.5%, you want to move the decimal 2 places to the left, or you can simply take 1.5, divide it by 100, and you'll see that the corresponding decimal is 0.015. Okay, so those are just 2 examples of how you'd actually convert the percent to a decimal. And then last but not least, T represents time. Okay, in 098, in this class, in 098, typically time will be in terms of years. But really, time could be any interval, days, months, years, etc. So what I want you to consider is that your rate of growth and your time must correspond to one another. So if you have a growth rate that is annual, your time must be annual as well, meaning number of years. If you have a monthly rate of growth, then your time should be in terms of months. Hopefully that's clear. So those two have to link up. For this course, like I said, typically we'll be referring to time in terms of years. So let's look at a few example problems of just using our formula, no big deal. So how much interest, please underline that. I find that when we underline the phrase that indicates what we're missing or what we're trying to solve for, it becomes very clear what all of our values end up representing. So how much interest, which by the way we know is I, interest, will be owed on a 5-year loan. So 5-year loan represents time of $25,000. So $25,000 is going to be our principal in this case at 7.5% simple interest. And there's our rate. Rate is percentage, bam. So notice we don't know I, but we do have T, P, and R. So in our formula, I is equal to P times R times T. What I'd like us to do is rewrite that formula. I is equal to P times R times T. Another way to remember that, commit that to memory if you'd like, is to say the phrase, I is pretty. It works, right? I is pretty. I equals P-R-T. Good morning, Maria. So little mnemonics that might help commit that to memory. I is pretty. Okay, let's continue. So we don't know the interest. We do know the principal is $25,000. Let's make that substitution. We know that we're multiplying that by the rate. The rate is 7.5%. As a decimal, that becomes 0.075, right? So we divide that by 100, essentially move the decimal 2 places to the left, so 0.075, and then times the time, and in this case, time is 5 years. You're simply going to notice that in order to solve this, you're just going to multiply left to right. 25,000 times 0.075 times 5. Don't overthink it. We're not distributing here. We're just multiplying these three quantities together. So your interest is going to be $9,375. Okay. Always make sure you include your units. That tells me that you understand exactly what it is that you're solving for. That's a very important. When you're working with all of these word problems, you should be thinking, what am I actually referring to? Does my answer make sense? So for instance, when we talk about the number of gallons in a solution, if you told me -2 gallons, that's a problem, right? That doesn't even make sense. I don't even know what that looks like. So you have to be careful that your answer matches the context of the word problem itself. Be very critical as you move through these. Let's take a look at the second example. What was the principal? So remember, we're going to get into the habit of underlining what it is that we're trying to figure out. So what is the principal? That means P is unknown. On a 4-year, so 4 years is our time. 6% loan, the 6%, that's rate of growth. If the simple interest was $2,040. So in this case, here's our interest. We're still going to write down our formula just like we have before. And part of the reason for doing that as well is to commit that formula to memory. It's just going to become second nature and you'll probably end up starting to dream about it. I'm not even kidding. So interest, which is $2,040, will replace I in our formula. We don't know the principal, so we're going to leave it P. I know a lot of you are comfortable with using X as your substituted variable, but remember that's just a dummy variable, so it doesn't have to be X. Let's stop using X all the time, okay? So P, principal, that's unknown. The rate is 6%. So in this case, 6% we're going to convert to a decimal, divide that by 100, or move the decimal 2 places to the left, so 0.06, and then the time is 4 years. So what I want you to consider is take a look at what it is you can do right now. So we have 2040 is equal to P times 0.06 times 4. Well, notice that these two quantities are on the same side and they're being multiplied together. So why not take the 0.06 times 4 and multiply that together? That gives us, and I'm just going to rewrite it here, 2040 is equal to P times 0.24. Okay, in this case, we're still trying to solve for P because this says P times 0.24. Well, that's simple. Thank you, Hannah. I'm about to prove that. So we know the opposite of multiplication is division. So we're going to divide both sides by 0.24. By 0.24. I hope the order didn't trip you up. Even though the 0.24 was after the P, we know they're connected by multiplication, which means we're just going to simply say and smoothly say the opposite is division. So we cancel those two out. That leaves us with a 1. So we have 2040 divided by 0.24, which is going to give us, as Hannah wrote in our chat, $8,500. This is our principal investment. On your own, I'm going to give you, let's just do 60 seconds. Don't overthink it. Try problem or exercise number 3. Give this a shot starting now. All right, let's take a look. So we have an answer coming in. Hopefully you're all getting something similar as well. Let's take a look. What was the rate? We don't know it, so I'm going to identify that the variable R is what we're looking for, at which a 7-year loan, so 7 years represents our time, of $32,000. Keep in mind, it's a loan of $32,000. That implies that it's our principal, right? The principal loan amount, $32,000, earned $19,040 simple interest. So you can only earn interest. So in this case, let's identify that $19,040 is our interest. Same thing, let's rewrite our formula. I is equal to P times R times T, or I is pretty. The I is $19,040. Our principal is $32,000. Our rate is unknown. We could put R in parentheses if you'd like, or we can leave R as is. I'll write it in parentheses because I kind of feel like you might be in that path. And then T is 7 years. Thank you, Claire. Let's take a look. So here's what your equation should look like when you substituted the given values. Now, I'm going to read this out loud. So $19,040 is equal to 32,000 times R times 7. Well, remember that multiplication is commutative, right? So for instance, if we had 1 times 2 times 3, that's the same as 2 times 1 times 3 is the same as 3 times 1 times 2, and I could keep going, right? So having said that, we know that we can multiply these two values together. So if we have 32,000 and we multiply it by 7, that's going to give us 224,000 times R. Notice how I take one step closer towards the answer and we do what we can do. Yes, excellent. Thank you, Noelia. So the next thing we're going to do is we're going to focus on isolating R. 224,000 times R, that implies we must divide. So we're going to divide both sides by 224,000. And then we're going to punch that into our calculator and take a look at what we see. So those cancel, leaving you with a 1. 1R is simply R. And then we have $19,040 divided by 224,000. That's going to give us an R value of 0.085. Now, notice it's asking, and that's okay, Hannah. Notice that it's asking for the rate. So what you'll want to do is you'll want to say that the rate is 8.5%. Okay? If when we convert from a percent to a decimal, we divide by 100, then we're going to do the opposite to convert from a decimal to a percent. We'll multiply by 100. So you move the decimal in 2 places. Okay? So we multiply by 100 to get the percentage. Okay? We multiply it by 100 to get the percentage, and that is 8.5%. Excellent work. Let's turn the page. Our next formula that we'd want to commit to memory is D equals R times T. Okay, in this case, we're talking about distance. So D represents distance. When you think of distance, please think of the phrase, how far? Okay, how far can be miles, kilometers, inches, feet, yards, meters, etc. So that's how far. Distance is how far. R in this case still represents rate, but when we talk about rate, we're actually talking about, and think of this logically, if you're in your car and you're going at a specific rate, you're talking speed. So how fast? If you're in your car here in the States and you're trying to determine the speed of your vehicle, you are talking miles per hour. Notice that rate deals with the distance and the time, miles per hour. You could be traveling kilometers per hour, right? And I'm going to use the slash to show that. You could be talking, let's say that you're looking at a cute caterpillar and you want to track how fast that caterpillar is moving. You're probably not going to stare at this caterpillar for an hour, but you might say, okay, well, how far in inches per minute is that caterpillar traveling? Does that make sense to everyone? So you're talking your unit of measurement for distance over time. That is your rate. Okay, and lastly, we have T, which is time. So how long? Is it minutes? Is it seconds? Minutes? Days? Etc. It could be anything, years, hours, whatever. Whatever that duration is for time, how long. All right, let's take a look at our first example. It says, find the distance. Underline that. We know that means that we're looking for the variable D. So find the distance traveled if a van travels 4.5 hours, so 4.5 hours, that's our time, at 65 miles per hour. So in this case, 65 miles per hour represents our rate. So let's rewrite our formula. D is equal to R times T. We don't know the distance. We do know the rate, which is 65. So notice this process follows the same as simple interest. And all of your formulas will follow this process. In this case, we have 3 unknowns. If I give you any 2, you can find the third. So time is 4.5 hours. And all we have to do is recognize the operation being presented. So in this case, we have 65 times 4.5, and that's going to give us 292.5. But we need a label here. D represents distance. Distance is how far. So find the distance traveled if a van travels 4.5 hours at 65 miles per hour. So that tells us our units are miles. Excellent. Give the next 2 a shot and go ahead and type those into the chat. The second example says, how fast is a car traveling if it travels 84 miles in 1.5 hours? And then how long would it take for a vehicle to travel 113 miles at 45 miles per hour? Give these a shot. Once I have a few answers in the chat, then we'll go over this together. All right, that's excellent. So tons of answers have come in through the chat. Let's take a look. So for our second example, how fast, that refers to our rate. So R is unknown in D is equal to R times T. How fast is a car traveling if it travels 84 miles? That represents our distance. In 1.5 hours, that represents our time. So distance is equal to rate times time. So distance is 84. Our rate is unknown, but we do know the time is 1.5 hours. So in order to solve for our hour rate, we're going to divide by 1.4. Wow, 1.5. Let's try that again. We're going to divide by 1.5. These cancel each other out, leaving us with a 1. And we have 84 divided by 1.5, which is going to give us 56. So keep in mind we're talking about the rate here. So we know we're traveling miles in hours. So our answer is going to be 56 miles per hour. Excellent, everyone. And thank you, Kayla. How long would it take? So how long would it take for a vehicle to travel 113 miles, there's our distance, at 45 miles per hour? That is definitely our rate. Also notice here it says round to the nearest tenth. So we want to be super careful with our rounding for all of these problems, especially when we're plugging this into lumen. Okay, so the nearest tenths is the first digit after the decimal. So as an example, 3.5, 5 is our tenths place. Okay, our tenths place. So if we have 3.5, let's say 8, this will round, because 8 is 5 or more, this will round up to 3.6. Okay, so that's essentially how we'll move through this process. So again, let's write out distance is equal to rate times time. Our distance is 113 miles. Our rate is 45 miles per hour. And our time is unknown. Same process, it's 45 times t, so that implies we're going to have to divide by 45. So we have 113 divided by 45 is going to give us 2.511111 repeating. So because we want to round to the nearest tenths, we're going to look at the 2.5 and then 1, our hundredths position. So because our hundredths position is less than 5, so 4 or smaller, we're going to leave it a 5 and not round up to a 6. So our answer in this case is going to be 2.5. It says how long, that means time, right? The length of time, and we're talking about hours here. So 2.5 hours is your length of time. Excellent job, everyone. Your answers look fantastic. So let's keep going. We're progressing quite nicely. We're now ready to do a brief overview of your geometric formulas. I would tell you that for sure, please consider committing to memory the formulas for a rectangle, and also maybe formulas for triangle and circle. So I want you to consider that you should really commit to memory those formulas especially, but you'll always have the opportunity to look at your geometric formulas list if you ever had to reference it while you were working on homework and things of that nature. So our first shape is our square. One of the properties of a square is that all 4 sides are the same. So what I'd like to do is I'd like to note that if these sides are all the same, we can call them S for side. So in which case, if I wanted to find the area of this square, it should make sense that we're essentially taking your vertical distance and multiplying it by your horizontal distance so that we could see how big of a space that takes. So area, think of area as like replacing the carpeting in a room, right? You have to take the dimensions of the room. Once you multiply the length and the width, you can figure out how much carpeting you would need for that space. So in our spot here for area, we notice its area is equal to side squared, or essentially side times side, okay? For your perimeter, perimeter is essentially the sum of all sides. So when we see the word perimeter, I want to write down sum of all sides. And that's really great because essentially I can give you any figure in any shape, and as long as I give you all the dimensions of the sides, you can always find the perimeter, right? Keep in mind we're talking about 2-dimensional shapes. We're talking about those flat shapes, not 3 dimensions. So if we were looking at 3-dimensional shapes, we're now moving into volume. Another point that I wanted to share with you is that area refers to, when we actually calculate, we're referring to units squared or square units. For perimeter, since we're essentially just adding all the sides, so adding each of these one-dimensional sides, so this is going to be simply units, whatever those units are. So for example, area can be feet squared, inches squared, meters squared, right? Measurements that represent length, but squared since we're talking about area. Another way to consider this is, what if we had 3 feet times 3 feet? Well, that's going to be 9 feet squared. Feet times feet, feet squared. There's 2 factors of feet there. If our measurements were 3 feet, then we have 3 feet plus 3 feet plus 3 feet plus another 3 feet to get the perimeter of that square, in which case it's 4 sides, so 4 times 3, which is 12 feet, not squared units, because we're just moving around the room. Another way to think of perimeter is, think of replacing the trim in a room, for instance, right? Or the crown molding. If this room had it, you would essentially be looking at the crown molding at the top and just measure that, around the room. Another way to think about that is maybe the casing for a window. So you're going to measure that casing. That's perimeter. So that's kind of another way to look at that. Hopefully that's helpful. In terms of our rectangle, I want to label the longer side our length and the shorter side our width. Not that that's always the same case. Obviously, that can be very dynamic. I don't want you to stay too stuck on that idea. But in this case, I'm going to call length the longer side and width the shorter side. In a rectangle, opposite sides are identical. So if this is the length, this is also the length. Here's our width, here's our other width, right? So if this was 8, our opposite side would be 8. If this side were 4, our opposite side would be 4. So the formula for the area of a rectangle is, you're going to take the vertical distance and multiply it by the horizontal distance. So length times width, that's going to give us area. A formula we can use to find the perimeter of a rectangle is 2L plus 2W. But honestly, you don't need a fancy formula to find the perimeter of any figure, because all you have to do is add up all the sides. So let's label these other 2 sides L and W, so that way you can see W plus L plus W plus L. That's going to give you the perimeter. Don't overthink it. When we work with geometric problems, we're always going to draw it. Next, we have the parallelogram. I'm going to label this distance our B, our base. And then height will go from your top base to your lower base. So here's our height. I drew here a right angle to show that this is perpendicular. This line, this vertical distance, is perpendicular to the base. So it tells us exactly how tall, so to speak, our parallelogram is. Area is base times height, and the perimeter, just add up all 4 sides. For a trapezoid, again, notice we have 2 bases here. We have a smaller base, which I'll call lowercase b, and we have a larger base, which I'll call capital B. In order for these to be the bases of a trapezoid, they must be parallel to each other. That's a notation we see in geometric proofs. This arrow here indicates that these 2 lines are parallel to each other. The height of a trapezoid will always be the vertical distance from the lower base to the upper base. Okay, that's going to tell you how tall your trapezoid is from base to base. The formula for the area of a trapezoid is half times the height times the sum of the bases. When you apply this formula, always think order of operations. So you may want to add the bases first and then multiply by half the height, or add the bases first, multiply by the height, and then multiply by a half. Multiplying by a half is the same as dividing by 2. Keep that in mind, okay? Half of, so half times the rest of it. Keep in mind you're not taking half of the sum of the bases and half of the height. You're taking half of one of them or half of the combined value. Keep that in mind. You're not going to multiply by a half twice. That doesn't make sense. For a triangle, we have half the base times the height. So let's label this side our base. And the height will essentially be from your vertex to the base. Again, I'm going to draw that right angle here. So this distance, that vertical distance, will represent the height. I could have labeled that inside of the triangle, but I just essentially wanted to show you it goes from the vertex to the base is the height of the triangle. And lastly, we have our circle. So I'd like us to put a point in the very center of the circle as best we can. And what we're going to do is we're going to draw a dotted line here. So notice this dotted line, it's half of this length that cuts through the center of the circle. So this is considered or called our radius. Okay. I'm going to draw another line that goes from one side of the circle through the center to the other side. That line that cuts the circle in half and goes from one end to the other is called the diameter. Okay? I want you to keep in mind that in any diameter, you have two radii. That should make sense. A radius is half the diameter. So I just gave you two formulas here that you may want to consider. So I told you that the diameter consists of two radii, right? So if the radius is 5, the diameter is 10. And then if you know the value of the radius, right, then you know that's the same as half the diameter. Okay, so if the diameter is 15, then the radius is 7.5. Good. Notice that every time I wrote these problems down, the word is represented the equals sign. Something to keep in mind so that we're ready for Unit 3. Our formula for the area of a circle is pi times radius squared. I would like us to use the approximation for pi of 3.14. So in class, what I'd like us to do, instead of pressing the pi key, which is here, I want us to actually type in 3.14. So let's say our radius was, 5. So we're going to do 5 squared times 3.14 to find the area of that circle. So the area of our circle will be 78.5. Now, imagine I do that again. The radius is 5, so 5 squared and then times pi. Notice the difference in our solution. So we're definitely more accurate with our pi using the actual value or as much of it as you can. But in order to be consistent, in order to have similar results, I would like us to use the approximation of 3.14. Do not use the pi key on your calculators. Next, we have two formulas. I apologize that they look like they're all connected. They're really not. So I'm just essentially going to cross that out and write it directly underneath. So C, our circumference, which represents perimeter, is equal to pi times diameter. Or another formula for circumference is 2 times pi times radius. We know this is the case because our diameter is the same as 2 radii. You see how these formulas are exactly the same. They mean the same thing. When you think of circumference, again, think of perimeter. So I want you to visualize essentially looking at like a clock, right? So you see a circular clock on the wall, and you want to say, well, what's the circumference of that clock? You could, if you wanted to, you could take a piece of string and wrap it around the clock and then figure out where it touches and then take that string, open it up and measure with like some sort of, ruler or measuring tape or something like that. So that's a very realistic, way we could do that physically in person. Another way to do that is by measuring the diameter or the radius of that particular clock and using the formula. So if you want to test that out, go ahead and take a look at one of your circular clocks or something that has like a circular shape, and use a piece of string, hold it to one end, wrap it around, open that up, measure it, and then use a formula and see if you get the same answer. Okay, I bet you will. All right, so let's continue with our notes. For our first example, again, we just briefly ran through this. A rectangular pillowcase measures 600 square inches. So first off, we have key pieces of information. We know that it's a rectangle. So what I'd like us to do is draw that rectangle. Anytime we have geometric figures where we can visualize the shape, we should draw it. Sorry, my rectangle is so busted. So here's my rectangle. It measures 600 square inches. Well, within our conversation, we learned that square inches refers to area. So the area of this rectangular pillowcase is 600 square inches. We're told that the length is 30 inches. So here's our length. It's 30 inches. So is this side, correct? So what is the width? So what I'd like to do is identify what it is we're trying to find. What is the width? In this case, I'm going to use W for width. If you are used to using X for all of your unknowns, get out of that process. Please don't do it anymore, okay? If we're talking about the width and that's our unknown, use W. It just makes sense. It ends up being a lot easier and clearer to you as you work through these problems. If it's length, L. If we're talking about a main character, Jose, use J, all right? Not H. That's not how you spell it, okay? It's not how you spell it. So we know we're looking at the area for a rectangle, which means we need the area formula for a rectangle. Area is equal to length times width. We go through the same process we went through with distance and interest. The area is 600, so we replace A with 600. The length is 30 inches, so we replace the L with 30. And what we don't know is the width. At this point, all we have to do is solve for width. So we're going to divide by 30, since that's the opposite operation of multiplication. 30 divided by 30 is 1, and 1 times W is W. And then we have 60 divided by 30. One thing I like to do right off the bat is notice that we can divide both of these by 10, which means those zeros cancel. And then essentially just becomes 60 divided by 3. Well, 60 divided by 3 is 20. So let's look at our units. We notice that the area was 600 square inches, and we also notice that the length is 30 inches, which means the width is going to be 20 inches. And that is your solution. I would like to stop there. That was fantastic. We'll continue through with our notes tomorrow. All right, everyone. Seeing that there are no more questions, have a wonderful rest of your day, and I will see you all tomorrow. Ciao.